In this video, we're going to look at problem solving with Surds, or like applications of Surds. So types of problems you'd be doing with Surds. Okay, remember it's to do with maintaining accuracy. That's why we use Surds. So let's just do these three little problems that I've got here. Again, if you feel confident you know how to do everything, you might want to do the worksheet that's attached. Remember, this one is the one I want you to submit, please. And actually, I want you to mark it as well. So do each question and then mark it, please. So that's kind of like the task. Okay, you can do as much of it as you want. You can do the whole thing, or you can do some of it. But I just want you to do the questions and mark it and then submit it, please. All right, let's get into these problems. Right, this is an easy problem. We need to work out the length of this side x here. So we have to use Pythagoras. So x is the hypotenuse. So x squared is equal to the other two sides squared. So that's root 8 squared plus root 10 squared. And that equals x squared. Now, you need to think about it in a logical way. If you square root 8 and then you square it again, then you just get 8. And then if you square root 10 and square it again, you get 10. So that's 8 add 10. And then that's 18. That's x squared. So x is equal to root 18. But if you were to leave that as your final answer, you'd probably lose 1 mark, because we want to simplify it as well. So 9 goes into 18 3 times. Sorry, what am I doing? Not 3 times. I was thinking twice. I don't know why I said that. I was thinking of 6 for a moment. So 9 times 2 is 18. And then the square of 9 is 3. So this is 3 root 2. That is how long that side is exactly. So that's the exact length. Okay, let's look at the next question. This one's a step up, so that was an easy problem. This one's a little bit harder. Okay, so we're asked to work out the area of the trapezium. Now, trapeziums, I find it annoying sometimes because there is a nice little formula that helps you work out the area of trapeziums, but sometimes I see students chopping it up into rectangles and triangles, and you're just generating more work for yourself. Just remember the formula for working out the area of a trapezium. The area of a trapezium is you take the parallel sides, which I'll label A and B. Oops, A and B. That doesn't look parallel at all. But you take remember the area is equal to the parallel sides added together times the perpendicular height, and then you want a half of that. You can write it like that, or you can write it like this, whichever way suits you. But basically A and B are the parallel sides, you add them together, times by the perpendicular height, and then you half it, and that's the area of trapezium. So let's do that on this particular trapezium here. Okay, so the parallel sides are this one and this one. So let's just add those two together first. So this is the A add B bit in the formula. That's going to be root 3 add root 3 add 1. That's the bottom, so that's 2 root 3. Add 1. That's your A plus B bit. The height is that. And then, so the area, let me do it here, is equal to a half A plus B times the height, so that's going to be a half. 2 root 3 is the parallel sides added together times the perpendicular height, which is that. Okay, and then we need to half that. So what I'm going to do is I'm going to expand those double brackets first. So I'm going to expand those double brackets first, and then I'll half that. Okay, so 2 root 3 plus 1 times root 3 take away 1. Okay, so that times that is 2 root 9. That times that is take away 2 root 3. That times that is just root 3, positive though. And that times that is minus 1. Okay, so that 2 root 9. Root 9 is equal to 3. Times that by 2, so that's 6. Take off the 1, that's 5. The middle 2, minus 2 root 3, add 1 root 3 is not positive, but negative root 3. So that's that. And then we just need to half that. So over 2. And then there's your answer. Okay, so that's the area of that trapezium. 5 take away root 3 over 2. Or you can write it as half, bracket 5 root 3. Or 5 over 2 take away root 3 over 2. Each one of these is equivalent. Okay, let's do the last problem. This one's a tough one. Okay, and the reason why this was a tough one is because this was the last question on an exam paper a few years back. I can't remember what year it was, but it was the very last question on the non-calculator paper, and lots of students complained about it that year. But you have it's not too bad. Let's go through it. Okay, you have to work out the area of this grey section here, and we're told that this is the most important thing actually that some students probably forgot to look at, was that this length AD is equal to this entire length BD. Now, root 3 over 3 is just this section from C to D. Now, I'm going to do it the easiest way in order to work out the area of that grey section. So the way I'm going to do it is I'm going to work out the area of the entire triangle. So I'm going to work out the entire area of this entire triangle. And then I'm going to work out the area of this little triangle. And I'm just going to take them away from each other. And that's going to leave, well, it's going to leave that, isn't it? Because logic dictates that it will. So the area of the big triangle, take away the little triangle. That's probably the easiest way to do it. So let's just do that now. So remember, the area of a triangle is a half base times height. Okay, or base times height divided by 2. So, right, so let's look at the big triangle ABD. That's the big outside triangle here. Okay, the base is root 2 over 2, and the height is the same. So we're going to have to do a half times the base. And I always like to write it out in full, times the height. So base times height divided by 2, or half base times height. Okay, multiplying fractions, dead easy, so easy. Multiplying fraction, multiply the tops. So 1 times root 2 is root 4. 2 times 2 times 2 is 8. And root 4 is a square number. Sorry, 4 is a square number. The square root of 4 is 2. So that's 2/8. That's a quarter. Okay, so the area of the big triangle is equal to a quarter. So now let's work out the area of the little triangle. Okay, the little triangle is again half base times height, so it's a half times the base is root 2 over 2. The height is root 3 over 3, because we're doing this triangle here, ACD. Okay, so badly drawn, sorry. Okay, multiplying the fractions, multiply the tops, you get root 6 on the top, and on the bottom you get 2 times 2, which is 4, times 3 is 12, so that's root 6 over 12. Okay, now the area of the grey section was the area of the big triangle, which is a quarter. Take away the area of the little triangle, root 6 over 12. And that is the answer. You can leave it like that. Or if you want to write it as one fraction, common denominator 4 and 12, common denominator is 12. So you could times top and bottom by 3 if you wanted on the first one. So you could write 3 take away root 6 over 12. That's also equivalent. That is the area of that section there. So remember, as the big triangle was a quarter, the little triangle was root 6 over 12. So there's two acceptable answers, that and that. Okay, right. Thank you very much for watching this, guys. What I'd like you to do now is the questions. Please can you mark the questions as you're doing them against the answers, and then submit that to me when you've done it all. Okay, if it takes you ages to do them and you've only done a couple of questions, I don't care, as long as you've done it, you've had a go at those couple of questions and it's your own working out and you haven't copied the answers, and you know I can see it. That's great. Okay, thank you very much, guys. Thank you for watching.